right, so let's get cracking. I want to talk to you today about a mathematical technique called completing the square. And this is something that you would learn when your teacher teaches you about quadratic equations and quadratic expressions. Before we get started on the technique of completing the square, something that a lot of us really struggle with is the difference, or to understand the difference between an algebraic expression. So I'm just going to write the word expression versus an equation. Okay, so if I want an example of a quadratic expression, it would be a collection of terms. So for example, something like x squared plus 3x is a quadratic expression, or something like x squared minus 9 is a quadratic expression. Or if I had a trinomial like x squared plus 3x plus 2, that is an expression. It is a collection of terms. Okay, so it is a collection of terms, and it can be one term, two terms, three terms. It really doesn't matter. Okay, when we are working with expressions, we are not concerned about the value of x. All right, so we are not solving for x. The value of x is unimportant to us. Either we are factorizing expressions or we are multiplying out brackets and collecting like terms. But what we are not doing is worrying about what the value of x is. Once we make an equation, now we are solving for x. We are solving for x. And we need to have an equals sign somewhere inside it. So for example, if I've got an expression x squared minus 9, and now I suddenly say to you, okay, grade 11s, I want to know what is the value of x or values of x that satisfy this equation. I need to have an equal sign. I need to have a left-hand side and a right-hand side. Okay, so it's very important that we understand the difference between an expression and an equation. So later on in this week, on Wednesday, Mr. S is going to show you how to use this technique of completing the square to solve equations. What I'm doing today is I'm focusing on this bit over here, the first bit, which is we're going to be using completing the square when we're working with algebraic expressions. So we're not trying to solve for x. What we are doing is that we are changing the form of our algebraic expression. So we are going from a form like this, where we have ax squared plus bx plus c. So it's in that form. And through the process of completing the square, we change its form. Okay, so after we complete the square, we have not changed the value of the expression, but we have changed the way in which it has been written. And the way in which it has been written gives us important information about the quadratic expression, which I will hopefully be able to get into today, but we'll see that probably will end up being your lesson on Wednesday, that he will go through that with you. All right. Safe to say that the values of P and Q become very important for us when we start placing these onto the Cartesian plane. All right, we start parabolas. So P and Q have a very specific meaning. They're very important to us in grade 11, but we don't really need to understand what that is in terms of a graph right now for this particular lesson. Before we get into the actual technique and how we do it, it's important for us to understand trinomials that are perfect square trinomials. So I've got an example of a few here on the board. I'm just going to move that down a little bit. Okay, so the first one that I want us to have a look at, okay, is number 1. It is a perfect square trinomial. So thinking back to grade 10, because that's the first place we would have seen perfect square trinomials, how can I factorize number 1? When it factorizes, what does it end up looking like? Can anybody tell me in the chat, what would I end up with if I factorized this perfect square trinomial? Anyone got any ideas as to what it would look like once it's been factorized? Yeah, quite right, Ayanda. Good, Annie. Yes, 2 brackets. Absolutely, there would be 2 brackets. And what could we say for sure about these 2 brackets? So if I call this expression t, and I say t is equal to x squared plus 2x plus 1, I want to factorize. I'm going to end up with 2 brackets. I'm going to end up with x over here, and I know that 1 times 1 is 1, so that has to be 1, that has to be 1. And then I get the middle term by adding and or subtracting, in this case, just adding. So because the middle term is positive and the last term is positive, both of these brackets have to have a plus 1 inside them. No Latabo, that's the whole idea. Okay, we are not equating this to 0 because we are not solving for x. We are working with an expression and not an equation. The value of x is not important here. Okay, we're not solving for x. What's important is that with number 1 and number 2 and number 3, they can all be written as perfect squares. Right, now I'm showing you this because it ties into what we were talking about over here. So I'm just going to grab this guy and bring it down here and show you what it is that I mean. Oh, sorry, that's not what I wanted. I want the expression. Hold on a second. Let me just get rid of the, here we go. Let's grab you and bring it down here. Okay, so the bit that I'm trying to show you here is this. Can you see I've got x plus 1 inside the bracket squared? That's this bit over here. That's where it fits in. Okay, so we have to be able to factorize perfect square trinomials. I want to show you now, well, in the next couple of minutes, where the second bit comes from. So where this plus q on the end comes from. All right, so I'm not completely finished with this. I haven't completed the square. I'm just showing you where the first part comes from, the x plus p squared, and why we need to be able to factorize perfect square trinomials. So now what I want you to do, right, is pick one, pick number 2 or pick number 3, and I want you to factorize it for me, just as I've done in number 1. Okay, so either you're going to do number 2 or you're going to do number 3, and I just want you to practice factorizing it. And I'm going to give you 3 minutes. Are there any questions? Well done, Jessica. That's great. Queasy. No, you don't have to do the last step. I just want you to factorize it. Okay, and write it as a perfect square. There we go. Very nice, Kumo. Okay, so now, Annie, if we had an expression like that, okay, if it was x plus 3 times x minus 3, when we multiplied it out in FOIL, we'd end up with x squared minus 3x plus 3x minus 9. That would give us an expression, x squared minus 9, which is not the same as the one that we have. So this is not difference of squares. It is a perfect square trinomial. It's a perfect square trinomial. There we go. Lovely. Well done. Sibabale, Sink, Cynthia. Who else? Yes, Masejo. Lovely. Well done. That's perfect. All right. So the first one would be written as x minus 3 times x minus 3. So that is x minus 3 squared. Good. And the last one, very good. Nice. Well done. Mangakane, I hope I said that correct. Yes, Pomelo, perfect. Beautiful. Oh, and somebody else even put it in there with lovely. Nokuzola, beautiful. Yes, Leander, 100%. Okay, so this would be written as x plus 4 squared, like so. All right, so the first bit is very easy because what we have to do is we have to factorize a perfect square trinomial. So let me go through the rest of the technique with you. All right. What we're going to do, sorry, actually, before we get started on that, is I just want to show you how we would determine what the last term is going to be. So in the first example here, we want to work out what the value of C is. Right, so let me show you what it is that we need to do. Okay, so in part A, they have given us x squared plus 4x plus C, and our job is to work out what the value of C is going to be, right? So when we complete the square, this is what we do, right? We take half of the middle term. So in this case here, the value, this is in the form ax squared plus bx plus c, right? So in other words here, a is equal to 1, b is equal to 4, and we do not know what the value of c is. So when we complete the square, we take half of the value of b. So whatever b is, in this case, it's going to be 4. So we'd work out what half of 4 is. So half of 4 is 2. We take that number and we square it. Okay, and we get 4. So that means that the value of c in this case is 4. So x squared plus 4x plus 4. My square is now complete. And if I wanted to factorize this, it would factorize into x plus 2 times x plus 2, which is x plus 2 squared. Okay, so that is how we would get that last bit, that value of P or C, sorry, on the end. Okay, I would like you guys to try B or C. Why are we using the 4? That is the method, Nakatenda. That is the technique. Okay, so there is a relationship between what the value of B is and what the value of C is in a quadratic expression. Sure, no problem. Let me do the next one as an example with you, because I know this is difficult if you've never done it before. Okay, so we've got x squared minus 10x plus c. We want to work out what c is. So we take half of whatever our value of b is, which in this case is 10. So half of negative 10 is negative 5. We're going to take negative 5 and we're going to square it. That gives us 25. So that means that the value of c is 25. Okay, so our perfect square trinomial is x squared minus 10x plus 25. And this factorizes into x minus 5 squared. Okay, so we've made it a perfect square trinomial by working out what the appropriate value of c is. The next one's going to be a little bit difficult. I tell you what, let me give you one to try rather than this one. That's not a very nice one to do as your first one. Let's give you this. So I'll call this question D. So x squared plus 8x plus c. So you guys work out what the value of c is. Just like I've shown you here in the pink and the orange. Can c be a negative number? No, it can't. And the reason it can't be a negative number, Koleka, is because a negative times a negative is a positive, and a positive times a positive is a positive. So it cannot be a negative number. Yes, so you multiply, not the second term, Nakutenda, the coefficient of the second term. Okay, so we need to know what our coefficient of our x term is. Okay, there we go. Nice, well done. Good, Masejo, good, Sakile, good, Annie, lovely, brilliant. Good, very nice. That's it, guys, well done. Okay, so you all went half of 8 is 4. I'm going to take 4 and I'm going to square it, and it's going to give me 16. So that means that C is equal to 16. Beautiful. Well done, everybody. That's lovely. Okay, so there we go. We're starting to complete the square already. We're just going to go on. Yes, and it could be written as x plus 4 times x plus 4. Lovely, 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 lovely. Good job. Okay, let's jump down here and let's go and have a look at this. Now, before I get into that, I just want to show you in a picture what it is we are doing when we are completing the square. And the first example that I'm going to go back to is something that we've already seen today, which is this idea of x squared plus 2x. Did you know that this is a rectangle? Did you know that? And if we were to draw the rectangle, this is what it would look like. Because if I'm going to factorize it, I'm going to end up with x times x plus 2. So up here, I'm going to draw myself a rectangle. Okay. This little bit over here, that's x. And this bit over here is the plus 2 part. So is everybody happy with that? So x times x plus 2 makes a rectangular shape. When we complete the square on x squared plus 2x, we make it into a perfect square. That's what completing the square means, right? Now, what I was showing you to do in order to complete the square here, you would all say to me, okay, so Lee, you've showed us. We would look at the value of b. Remember, a is equal to 1. B is equal to 2. And I've shown you guys to take half of the value of b, so half of 2 in this case, which is 1, and then you're going to take 1 and you're going to square it. Okay, and that's going to give you 1. So now for the square to be complete, it's now x squared plus 2x plus 1. Now let me show you in pictures what it is that we are doing, all right? Remember, we took half of the middle term. So what I'm going to do is I'm going to split 2. I'm going to split 2 into 1 and 1, but I'm going to call this part A, and I'm going to call this part B, right? Just let me show you the diagram, and then I'm going to show you, I'll happily take your questions, right? So remember, I've got my block over here, which is x, or x squared, okay? I'm going to leave part A where it is, okay? So that's over there. And then I'm going to take part B and I'm going to move it, right? And what I'm going to do is I'm going to put it over here. So here's B now. So I've twisted it and I've put it over there. This is not a perfect square, is it? Because it's made like an L shape, right? But the bit that now represents A, this is now 1 unit long. Remember, I halved it. So I had 2 originally, I had 2 here originally. I halved it. So now I've got 1 and I've got 1. So now here I've got 1. So now in order to complete the square, I need to take that 1 and square it and then add it on. And now I have a perfect square. So this bit over here is the 1 by 1. Okay, so that is in pictures what it is that we're doing. Okay, which is sometimes a bit difficult to either it's something that makes perfect sense to you or it's something where you look at it and you're like, and what? But hopefully you're not feeling like that. Okay, Kopana, what is it that you wanted me to repeat? Which bit? Okay, Kopana, maybe you want
to... Should we? I'm sorry, Teacher Lee, I was going to ask if we can take a question from Bianca in the meantime.
Yes, of course. Yes, with pleasure. Go for it, Bianca.
Hi, ma'am. Ma'am, I am very lost. So could you please explain the formula and then you move on to the rectangular? Because I got confused by the rectangle from when you move from the formula to rectangle. So can you please explain the formula first and then slowly go to the rectangle?
Okay, so what I'm trying to do with the rectangle and the square is I'm trying to show you in pictures what you are doing algebraically. Okay, so the whole idea behind completing the square is that you are taking an algebraic expression and you are making it into a perfect square. That's the idea. Okay, so maybe what I must do is the example that I've got below, right? And now this is the one that I was trying to do here, and I'll show you what it is that I'm trying to do. Okay, this one over here, it is written in the form, this expression over here is written in the form ax squared plus bx plus c. When I am finished completing the square, it's going to be in this form over here. So it's going to be in the form a times x plus p squared plus q. That's what completing the square does. So we take it from one form. It is a technique that allows us to take it from one form, standard form, and write it in such a way that we can see what the values of P and Q are, which are the turning points. Okay, or we can look at Q as the maximum or the minimum of our expression. So if I now want to complete the square on the first one, all right, I've been given x squared plus 2x. What I'm going to do is I'm going to take half of the middle term, which is 2, and half of 2 is going to give me 1. All right. Now, in order to complete the square, all right, I need to take that value, whatever it is, and square it. So in this case, it's 1 by 1 squared, which gives me 1. Okay. If I now take that and I add it on here, I have gone from it being a rectangle to being a square. Okay, now the reason for that is because x squared plus 2x looks like this. Okay, it's a rectangle. So if that bit over there is x and that bit over there is x, and I add 2 on at the end, it's going to make a rectangle. But if I have x squared plus 2x plus 1, it's a perfect square because on one side of my square, I have x plus 1. On the other side of my square, I have x plus 1. Okay, and now it's a square. Does that make sense to you? That's what I'm doing. All right, so hopefully that makes, which formula? No, you never have to do the drawings. The drawings are just there to help you understand the process that you're going through. Okay, it helps you to understand what the idea of completing the square is. You don't have to do the drawings. It's just there to help you understand. Okay, so if we take let's take question C now. All right, and let's complete the square. All right, so in question C, we have been given x squared plus 8x plus 10. Okay, so this is what we're going to do. We're going to keep the x squared plus 8x together, and then we're going to leave a space and we're going to put the plus 10 at the end. Now I want to complete the square. So what I'm going to do is I'm going to work out half of 8. Half of 8 is 4. So I've got to take 4 and I need to square it and I get 16. So now I'm going to add 16 over here. This is now my perfect square trinomial. But I've got a tail on this. I've got the plus 10 at the end. But because this is an expression, I am not allowed to change its value. So if I plus 16 at the front over here, I have to balance that out, which means that I need to take away 16 at the end so that I have not changed the value of the expression. So now my expression looks like this. I've got x squared plus 8x plus 16. And then at the end, I've got my tail. So 10 minus 16, sorry, that would actually give me a negative number. So I'm adding a negative. So here I would end up with negative 6. Now I'm going to factorize my perfect square trinomial. So we've practiced this before. We've seen this one in this lesson. And this factorizes into x plus 4 squared minus 6. And there we go. We've gone from standard form. So ax squared plus bx plus c to what we refer to in maths as turning point. Okay, so in other words, a times x plus p squared plus q. Okay, now I can see there are some hands up. Yes, we do. We do have C. Umta, that's quite right. We do have C. Okay. No, Kapana, there's no short method. Okay, there's no short method. This is the only way you can do this. So Sipakazi, the reason that you are minusing 16 is because this is an expression. So if you add 16 to it, you've got to balance it by taking 16 away. All right, so otherwise you're changing the value of the expression because I'm putting 16 in. So I've got to balance the fact that I've put 16 in with taking 16 out. Okay.
Ms. Lee, are you able to take a question from Katleho?
Yes, with pleasure. Go for it, Katleho.
Katleho, I'm asking you to unmute. Okay, nothing there. I think we lost them. Should we go to the next hand, Ms. Lee?
Yes, with pleasure. It's Masejo. Go for it, Masejo.
Hello, ma'am. Can you hear me?
Hello. Yes, absolutely.
Okay, ma'am. So my question was, I understand how we got the 16, but if we already had the 10 there, why do we have to find the 16?
Because x squared plus 8x plus 10 is not a perfect square trinomial. So in other words, if you want to, okay, it's not a perfect square trinomial. So what you need to do is that you need to write x squared plus 8x plus something to make that part a perfect square trinomial. And then the terms that are left over on the end, so the plus 10, that has to be balanced out by taking 16 away, so that the value of our expression is not changed. Because remember, the whole idea is we want to make a perfect square, and then we're going to collect our like terms together. So the plus 10 minus 16.
Okay, ma'am.
Okay.
Thank you.
All right, no problem. Yes, you can multi, absolutely. So in other words, Nokutenda, we can do this with a negative number as well. Quite right. So let me show you one with a negative number. So let's pretend we want to complete the square on this expression. Okay, so we've got x squared minus, let's choose a nice even number, let's say 4x. And then on the end here, let's put plus 9. Although we don't need plus 9, we could have anything. So now if I want to complete the square here, to change its form, okay, I'm going to keep the x squared and the minus 4x together, and I'm going to put the plus 9 at the end. Then I'm going to work out what half of negative 4 is, and that gives me negative 2. So I must take negative 2 and I must square it, and that's what I need to add on the end here to make a perfect square trinomial. Because this is an expression, if I add 4 in, I've got to balance the expression by taking 4 away. Now I factorize my perfect square trinomial. It factorizes into x minus 2 squared, and now I combine my like terms at the end. All right, so plus 9 minus 4 leaves me with plus 5. Okay, and now it is in turning point form. No, so the only thing that you have to do is that whatever you add, you have to subtract. So we're not worried about changing the signs of what's there. We're balancing what we're adding and subtracting. So if I gave you an expression and I said to you, here's an expression, x squared plus 3x, right? If I add 2 onto it and then take 2 away, I haven't changed that this is still equal to x squared plus 3x. So I'm not allowed to change its value, but I'm allowed to manipulate by adding and subtracting the same thing, okay, in order to keep it balanced. Ah, very good question, Nakatenda. Well, then let me show you what happens here, okay? Let me show you what happens if it's a, did you mean an odd number, Nakatenda? Yes, it's an odd number. Okay, so let's show you what happens. Okay, so let's make something up. Okay, let's pretend now we've got x squared plus 5x plus, we'll slap 3 on the end. Okay, so now we want to complete the square. So we've got x squared plus 5x. We're going to leave a space there. We're going to put our 3 over here. And now, Nakatenda, we've got to take half of 5. Half of 5 is 5 over 2. I've got to take that and I've got to square it. This gives me 25 over 4. So now I'm going to plus 25 over 4 at the end. And here I'm going to take away 25 over 4. Let me just draw a block around that. Here is your perfect square trinomial. It's going to factorize into x plus 5 over 2 squared plus 3 take away 25 over 4 is going to leave me with, sorry, it's not a plus, it's a minus because what I've taken away is bigger, minus 13 over 4. So that's what would happen if it was odd. Okay. So yeah, you can get a fraction, Annie, and that's exactly how you would deal with it. Okay, so remember when you square a fraction, you are squaring the numerator and you are squaring the denominator. Okay, I see there's another question. Orikonisa, I hope I said that correctly. Do you want to ask a question? You're welcome to unmute.
Hi, ma'am.
Hey.
I wanted to ask, instead of doing it the way you are doing it, I mean, like, if it's x squared plus 5x plus 3, instead we divide the 5x by 2, and then what we get is going to be x squared plus 5x, and then plus 5 over 2 squared, and then we say minus 5 over 2 squared plus 3 instead, and then you solve the first, you put a big bracket over x squared plus 5x plus 5 over 2 squared, and then solve it, and then you can write the other, the other answer you got. Yes, because this one for half is confusing.
Yeah, no, absolutely. You can do it that way as well. It's exactly the same thing. It's no different at all. Okay. All right. No problem. Okay. Yes, absolutely. Absolutely, you can write that in your test. And if they say to you that you need to do something by completing the square, then you've got to be able to go through this method, because sometimes in grade 11, they do specify that you have to use this particular technique. So, and it's also important for you next year when you go into grade 12 and you do analytical geometry, you need to be able to complete the square. So I'll tell you what, I've done lots and lots of talking here. What I think we should do is go down here, and I think you should practice completing the square. Here are 3 that you can try. All right, so complete the square for each of these, and let's see how it goes. So Nakatenda, you can leave it as a decimal if you want to. Generally in maths, we try not to write things with decimals unless we've solved something using the quadratic equation or whatever. But it's fine. If you want to press the SD button, it's not a problem. Okay, 100%. Okay, so let's try this. Yes.
We have a question from Itumeleng.
Yes, with pleasure, Itumeleng. So everybody else carry on, and I'm gonna help Itumeleng. Go for it.
Okay. Hi, ma'am.
Hi, Itumeleng.
Okay, so ma'am, like I'm stuck on that one that says 5 over 2. So I wanna know how did you get that 5 over 2 when there's 24 over 4?
Okay, so we had x squared plus 5x, and if Was it +3 on the end that I said? Yes, it was +3 on the end. Okay. So we have to take half of b. B is the coefficient of x. So what I'm going to do with my expression is I'm going to leave the x squared and the 5x together. I'm going to leave a space, and then I'm going to put my +3 at the end. Now, what I was doing is I was working out what half of 5 is. Half of 5 is 5/2. Okay, so if you do that on your calculator, half of 5 is 5/2. Then you've got to take that number and you have to square it. So that is where the 25/4 comes from, because 5 squared is 25 and 2 squared is 4. This is the number that you need to add in here to create your perfect square trinomial. So this thing with the green brackets around it is your perfect square trinomial. So you're not allowed to just add 25/4 into an expression, because now I've changed the value of expression by adding 25/4. So in order to balance out what I'm doing, I have to take 25/4 away as well on the same line. So what was in the green brackets now becomes a perfect square trinomial. It factorizes to x plus 5/2 squared.
So,
And
ma'am,
yeah.
so, ma'am, the 2 is from the 4.
The 2 is from the 4, yes, because 2 squared is 4, correct.
Okay, thank you, ma'am.
Okay, no problem. And then I'm going to combine my like terms here at the end into one term. So now you can see I originally had it in the form ax squared plus bx plus c. And now it's in the form a times x plus p squared plus q. So it's a technique that allows me to rewrite my quadratic expression in a different way. It still has the same value. It still means the same thing. I have just written it in a different way. Okay.
Thank you, ma'am.
No problem, Itumeleng. Okay, so now I see there are some hands raised again. Who's got a hand up? Okay, so I think Itumeleng's question we dealt with. Masego?
Ma'am, may you please go back so I can take a screenshot of the notes?
Yes, with pleasure, Masego. No problem. Is that all you wanted me to do?
Yes, ma'am.
Okay, no problem.
Thank you.
Okay, so that's where you wanted me to be.
Yes.
Okay,
Thank you, ma'am.
it's a pleasure. Okay, so Annie, you're getting the right idea. Owam, you've got the right idea. Okay, so it has to be written in that form. Okay, that's looking good, guys. Okay, so I'm going to go down here. So as far as A is concerned, A is one of those that it's so easy it becomes difficult. So if I have now completed the square, I've ended up with x squared minus 4x. And then at the end here, essentially what I've got is 0. So if I work out half of -4, I'm going to end up with -2. I've got to take -2 and square it, and I'm going to get 4. So what I'm going to do is I'm going to plus 4 over here, and then I'm going to minus 4 on the end. This is going to become my perfect square trinomial. So I'm going to end up with x minus 2 squared, and then at the end I have minus 4. Okay, as far as D is concerned, I've got x squared minus 6x. I'm going to put my plus 8 over here. Completing the square, half of -6 is -3. I've got to take -3 and square it. That gives me 9. So I'm going to add in 9 here, and I'm going to balance it by taking 9 out. That's my perfect square trinomial. Okay, so this is going to factorize to x minus 3 squared minus 1, which is what some of you did. Okay, Vivian, you've got a hand up. Let's have a listen. What's up? Yes, Luyanda, good. Hello.
Ma'am, for A,
Yes.
minus 4x, don't you take the minus 4 and then you times it by a half?
I did. So I took the minus
Okay, ma'am,
4
sorry,
over here.
Okay, sorry, ma'am, I made a mistake there.
It's okay. It's okay. This is difficult. Okay, it's the first time you've ever seen anything like this, and this concept takes a while before we begin to actually understand what it is that we're doing here. So I really don't mind. Ask lots of questions. It's no problem at all. Okay, Sianda, what did you want to say?
So, Miss, can you repeat number A for me?
Sure. All right. So what is it that you didn't understand in A?
Is that the equal sign from there into x minus 2, those brackets squared and minus 4?
Yes.
Can you please show me how did you get it?
Sure. So I started off with x squared minus 4x. So x squared minus 4x is the same as x squared minus 4x plus 0. So in other words, I've got nothing on the end. So I'm just putting that plus 0 there as a placeholder for you. So in this one, I've got plus 8. In this one, I've got minus 8. If I've got x squared minus 4x, I'm essentially adding 0. So what I was showing you is I'm going to keep the x squared minus 4x together. And I'm going to put my plus 0 over here. I'm going to complete my square by taking half of negative 4, which is negative 2. And then that's the number that I have to square. That gives me 4. So now I'm going to come along and I'm going to plus my 4 over here to make my perfect square trinomial. And then I'm going to balance my expression by taking 4 away. My perfect square trinomial factorizes to x minus 2 squared. And 0 minus 4 is negative 4.
Thank you.
Okay, no problem. And it would be exactly the same process over here. This one would just be a little bit more difficult because we've now got an odd number. So what we would do here, because I know somebody was asking about this question, x squared plus 3x, let's put the minus 8 over there. We're going to work out what half of 3 is. It's 3 over 2 or 1.5. And that's what I have to take and I have to square. That's going to give me 9 over 4. So I'm going to plus 9 over 4 over here to complete the square. And then I've got to take 9 over 4 away. This now factorizes to a perfect square trinomial. So this becomes x plus 3 over 2 squared. And then I've got to take negative 8 and subtract 9 over 4 from it. And that leaves me with minus 41 over 4. Okay. Yeah, so you could use the 0 as a placeholder, Simangele, if that helps you. Okay, I don't know if it helps to have the 0 there as a placeholder.
Miss Lee, are you able to take a question from
Yes,
Siphokazi?
of course, with pleasure. Who's asking a question? Cool, Annie.
Siphokazi.
Hi, ma'am.
Sorry, Siphokazi. Hi, Siphokazi. Go for it.
Ma'am, for A, ma'am, why did we add 0?
Siphokazi, I was just using it as a placeholder. Okay, so I don't have to add the 0 there if I don't want to, but I thought you guys might find it confusing if there wasn't a value there in the place of C. Okay, so if I wanted to do this, I can do this. It's going to give me the same answer. So I've got x squared minus 4x. So now I want to start the process of completing the square. So that's going to give me x squared minus 4x. And again, I'm doing the same thing over here where I'm working out what half of negative 4 is, which is negative 2. That's the number that I take and I square. Now I've got 4. So now I've got plus 4 here. So now I'm minus 4. There is my perfect square trinomial. So here I'm going to end up with x minus 2 squared minus 4. Okay, so whether the 0 is there or not, it's not going to make any difference.
Miss Lee, can you please
Yes.
explain how you got the 3/2 again?
Yes, with pleasure. Okay, so 3/2, remember that's what I'm squaring. So if you've got 3/2 and you square it, it means you're taking 3/2 and you're multiplying it by itself. So when we multiply fractions, it's numerator with numerator. So 3 times 3 is 9 and 2 times 2 is 4. Okay. Oh, Mangakani, I'm so glad. I'm so glad that it makes sense. That's wonderful. I'm so pleased. I was a bit worried there that maybe I wasn't making any sense, but I'm so glad to hear that this is a little bit better. So why did I change it back to 3/2? I didn't change it back to 3/2. Remember, right, when I'm writing it as a perfect square trinomial, what I'm doing is I'm factorizing my trinomial. Okay, so x squared minus 6x plus 9 factorizes into x minus 3 squared. All right, in the same way that x squared plus 3x plus 9/4 is going to factorize into x plus 3/2 squared. Okay, I think what I should try and do is just give you guys. So is it not pretended? Okay, so it's when you factorize your trinomial, that's how you know what to write inside the brackets. So for example, if we go back up to where we were earlier, here, if I now wanted to complete the square here on this one, okay, I've got x squared minus 9x. I'm now going to complete the square. So I've got to work out what I need to add and then subtract. So half of -9 is -9/2. Then I've got to take -9/2 and I need to square it. That gives me 81/4. So I'm going to add 81/4 and then I'm going to balance it by taking away 81/4. This is my perfect square trinomial. Okay, so this is what's going to factorize. Okay, and it factorizes into x minus 9/2 squared. Okay, so that's where that minus 9/2 comes from. And then I've got to bring down the value of q. Okay. So in Corsi, they will tell you to do that, but that's not even going to be an exam question, okay, or a test question. The sorts of questions that you're going to get in tests are the ones that I have done here with you this evening, okay, where you would have to go and complete the square. So tell you what, why don't I give you guys, that's a bit more difficult. Let me give you 2 more to try. Okay, so I'll give you an easy one and a difficult one. So here, let's go with x squared minus 6x plus 4. Okay, so you're going to complete the square on that. Or if you're feeling brave, you can try that one. Okay, and let's see if we can end on a positive note. Pleasure.
Keep going, guys.
You're welcome to share your answers. Apiwakule, that is lovely. You just got your sign wrong. It's supposed to be x minus 3, but that's very good. Luyanda, that's perfect. Jessica, I wanted to do ones like this today, but we're just not managing. What we would have to do there is take the 2 out as the highest common factor. Yes, yes. Sitsaba, Annie, very good. Okay, so Jessica, just very, very quickly, while we're just waiting for people to finish with this one. If you've got 2x squared plus 7x minus 10, let's say, you'd first have to take 2 out because you can't complete the square if the 2 is there. So that would be x squared plus 7 over 2x minus 5. Right, and this is where it starts to get a little bit yucky because now you've got to complete the square. So you've got x squared plus 7 over 2x. Then you've got your minus 5 over here. And now we're going to complete the square. So in other words, what we'd be doing is taking half of 7 over 2. So that would give us 7 over 4. And then that's what we need to square. So that would give us 49 over 16. So I would need to add in 49 over 16 here. Take 49 over 16 away. Here's my perfect square trinomial. So this gives us 2 times x plus 7 over 4 squared. And then minus 5 minus 49 over 16 leaves us with negative 129. Sorry, because I'm just making this up. So that's why these numbers are horrible. And then the last thing you'd have to do, Jessica, is multiply the 2 in. So you've got to multiply the 2 with the first bracket and the 2 with this as well. So you're going to end up with 2 times x plus 7 over 4 squared. And then times that by 2 leaves us with minus 129 over 8. Okay, so you better just take a screenshot of that, Jessica. Let's just go up to these ones. Okay, so with the first one over here, there are a lot of you that had the right answer. This ended up being x minus 3 squared minus 5, which was awesome. And then this one over here, you should have had x minus 5 over 2 squared minus 37 over 4. Let's see. There we go, 13 over 4. There we go. That's it. Okay, so I can see there are some of you. Yes, Nokuzola. There's a few of you that have got the right answer there. Okay, so just be careful. If the middle term is negative, then there's going to be a negative in your bracket. Okay, if your middle term was positive, we'll just go up and have a look. If you look at this one over here, if your middle term was positive, then inside your bracket, that's a plus. Okay, so just be careful of your signs. Okay.
Miss Lee, are you able to take some questions?
Yes, I'm just mindful of the fact that we've got to do the second one, but that's fine. Let's go for it.
Okay.
Good, Chuma. I'm so glad.
Hi, ma'am.
Hi there. What do you want to ask me?
Ma'am, by the previous questions, I think it was G. Yes. Right?
Yes.
By G. I don't understand, ma'am, why we didn't in the brackets, right? The
Yes.
x squared plus 3x plus 9 over 4.
Yes.
I understand that you have the 9 over 4, but I don't understand why we didn't put the 3x in it.
Okay, so when I halved, so what I did is I didn't halve 9 over 4, I halved 3. And then when I got half of 3, I squared that. And that's what I added in and subtracted off. Okay, so when I refactorize my perfect square trinomial, it goes back to x plus 3 over 2 squared, because if I might multiply x plus 3 over 2 with x plus 3 over 2, I'm going to get x squared plus 3x plus 9 over 4, because it is a perfect square trinomial.
Thank you.
Okay, all right. Yes, Annie, you would have to divide by 2. Okay, you would have to. So in other words, if you want to complete the square, and there is a coefficient on the x squared term, you would have to take that out first. Okay.
Miss
Oh,
Lee,
I'm
is
so
it
glad.
possible to
Yes.
sorry, Miss Lee, is it possible to scroll up a bit so they can take screenshots?
Yes, sure. To where?
I'm not sure. To where, Mangakane?
Oh, it's a pleasure, Pamela. I'm glad. Retabile, you get the 37 over 4. Where is it now? So this question over here. So the 37 over 4. So with this one over here, you've got x squared minus 5x, and then you're going to put the minus 3 over here. You're going to take half of negative 5, which is negative 5 over 2. Oh, excuse me. And then you're going to take negative 5 over 2, and you're going to square it. So that's going to give you 25 over 4. So here you're going to add 25 over 4, and here you're going to minus 25 over 4. So it's this bit over here that becomes negative 37 over 4. Okay, and then your perfect square trinomial, the x minus 5 over 2 squared is there. Okay, so it's from combining those two last terms